Good morning, guys. This is Mr. Champlin here, and I want to talk to you about random variables. We're starting a new unit, and we're going to be talking about probability distributions. And the first thing we need to discuss before we talk about probability distributions is random variables. All right. So a random variable is has a value that depends on an outcome of a phenomenon, the outcome, right? So, for example, we're going to look at a coin is flipped 3 times, and we're going to let the random variable x represent the number of heads you get when you flip. All right, so I just quickly drew up a sample space, and notice how like I have h is my heads and t is my tails, and notice like there's like if you want 3 heads, you have h h h. If you have 2 heads and a tail, you have h h tail or h h t. So how do we write out these random variables? All right. Well, x is the number of heads, right? The number of heads. So what will be the value of 0, 1, 2, or 3? Well, if the coin flips no heads, the only option is 0, right? Like you can't have any heads. If it flips 1 head, you have one option, right? Because you're only going to get 1 head. All right. And then if the coin flips 2 heads, then you're going to have 2. It's kind of making sense. And if you flip 3 heads, you have 3. Because your max can be 3 heads, right? Your max can be 3 heads because you're flipping the coin 3 times. You can't have 4 heads because there's not 4 coins. All right. So we're just taking the outcome and giving it a value. All right. So hopefully that makes a little sense. But we can get a little more specific, right? If a random variable takes on a finite number, this is important. So finite, so that's like a very specific number of values that can be counted for. You can literally count it. It is called a discrete random variable. So this is going to be called discrete. And looking at an example, you have a number of phone calls made by a telemarketer. Well, a keyword is number. So usually they give you a keyword like number. Keyword number. You can count how many phone calls. You can count the phone calls. Sorry. Number of phone calls. Number of calls. And yeah, so that's the trick to figuring out discrete. It's a straightforward number, right? However, there is similar to finite or infinite is random variables called continuous. And continuous variables are determined by the means of a measuring scale. So you're always going to look for like some sort of measurement. Like how can I explain it? Amount of time the telemarketer. So let's looking at the example. Amount of time the telemarketer spends on the phone. So this measurement is time, right? And the reason why it's not a set number, like the number of phone calls as the last example, is because you can look at time in many different ways, right? So you can look at seconds, you can look at minutes, hours, and so forth. So like your scale can be like infinite. You can just look at all these infinite numbers. You don't have a very specific, because you could say, oh, I have 33 seconds on this phone. Also, your the amount of time the telemarketer spends on the phone isn't determined, right? You could end up being on the phone for a long, numerous time. So really, the key trick to figuring out the difference between discrete or continuous is discrete will have a number and continuous will have a measurement. All right. So let's take a little more depth look, right? So here's a good chart. I like this. And again, it shows the differences, right? Straightforward with you, right? So you have your discrete, where it takes on a distinct possible value. So maybe think of discrete and distinct, and counting is always a word. So some great examples: number of siblings you have, number of students. And remember, I always said that key word is going to be number. Whenever you see number, it's going to be discrete. All right. So number of students in a math class, number of ultimate chocolate cakes Wegmans sells. All right. And then looking at the difference is continuous. Wow, that came out awesome. Right. So continuous takes on a range. That's a good word too. Range of values, right? So it's like an interval. And it can use decimals too, decimals and fractions. All right. So, but again, the key word is it's a measurement. And some examples would be like your height, volume in a water tank, the length of a worm. So see, these are all types of measurements. All right. So again, keyword for this one is measurements. All right. Let's do a couple examples. All right. So for the next section, determine if the random variable is discrete or continuous. So the first one says the number of books in a university library. Keyword, number. So if it has a number, it must be discrete. Number 2, the length of time it takes to get to work. Well, length and time are measurements, so this is going to be continuous. Number 3, the volume of blood drawn from a blood test. Yep, volume is a measurement, so it must be continuous. The number of tornadoes in May. Keyword, number. Must be discrete. Number 5, the exact amount of snow in inches. So this one is kind of tricky, right? Because they say the exact amount. However, it's a measurement because it's in inches. So this is going to be continuous. If it's a measurement, it's continuous. The number of tails after flipping a coin 3 times. Keyword, number. This is going to be discrete. How fast a person can walk. Well, fast is a pace, which I would say is a measurement. So I'm going to say this is continuous. And finally, the number of sick days a teacher has. And that is kind of ironic because I'm making this video because I am sick today. I apologize, I'm not in class. So that's ironic that is the last question. And if you caught on, the keyword is number. So this is going to be discrete. So hopefully this made sense. Hopefully you can do the next assignment pretty easily. Have a great day. I will see you guys in next class, and hopefully I will be ready to rock and roll then too. All right. Have a great one. Thank you very much. Mr. Champlin's out. Bye.